So, when you stand in front of a massive suspension bridge, you get this immediate, I don't know, this awe-inspiring sense of engineering.
Oh, absolutely. It's incredible to look at.
Right, like you see the thick steel cables and the massive concrete pillars, and you can just see the precise distribution of weight and tension.
Yeah.
You look at it and inherently understand that this entire structure is specifically designed to fight gravity.
Yeah, to handle dynamic loads and basically keep a tremendous amount of weight perfectly supported against these sheer physical forces.
Exactly.
Because every single bolt, wire, and beam on a bridge like that is placed to solve a very specific problem of physics. I mean, if one calculation is off, the entire load-bearing architecture is just completely compromised.
Well, what if I told you that the exact same level of structural engineering, that same battle against gravity and kinetic energy, is sitting right now, just folded up in your gym bag?
That is a great way to put it.
Okay, let's unpack this. Because today we are taking a deep dive into the hidden mechanics of everyday activewear. We've got a comprehensive guide on sports bras for you today, and we're pulling from physiological research, material science, and the technical R&D processes of apparel design specialists like the team at Apparelizer.
Which is such a fascinating angle to take.
It really is.
Yeah.
Our mission here is to show you why choosing the right sports bra is not just some mundane shopping chore. If you are wearing the wrong gear, you are actively causing permanent microtrauma to your body.
Right. And to understand why that is, we really have to completely reframe what a sports bra actually is.
Okay, how so?
Well, it is not just a piece of clothing. It is a highly technical piece of equipment that's engineered to solve a very specific, very demanding biological problem.
Biological problem, meaning the tissue itself.
Exactly. When we look at the anatomy, breast tissue contains absolutely no muscle.
Wait, none at all.
None. It is entirely composed of fat, glands, and something called Cooper's ligaments.
Cooper's ligaments. Okay.
Yeah, they're these thin, fibrous bands of connective tissue that basically help maintain structural integrity.
So unlike, say, a bicep or calf muscle, which can stretch and contract and, rebuild itself, these ligaments don't have that kind of elastic memory.
They do not. Not at all.
Wow.
Think of Cooper's ligaments more like a rubber band that has been left out in the sun.
Oh, that sounds bad.
Right. They have a clear breaking point. When you engage in intense physical activity, breast tissue doesn't just move up and down. What's fascinating here is that biomechanical studies show it actually moves in a complex figure-8 motion.
Figure 8, like all over the place.
Yeah, up, down, side to side, and forward and backward. During a high-impact workout like running, that tissue can move up to 8 inches in any direction if it's unsupported.
8 inches. That is wild. 8 inches of displacement for every single stride?
Yes.
I mean, when you multiply that by a 3-mile run, the amount of kinetic force pulling on those fragile ligaments is just staggering.
The force is immense. And because those Cooper's ligaments lack elastic memory, like we talked about, once they're stretched past a certain point, they just do not snap back.
So the stretching is permanent.
Exactly. The stretching is permanent. This is why the source material emphasizes that a regular everyday bra is functionally useless in a workout.
Because it's just not built for that.
Right. An everyday bra is built for static support, just holding a shape against mild everyday gravity. It does absolutely nothing to arrest that violent figure-8 kinetic energy.
So basically, if you wear a regular bra to a high-intensity workout, you might as well be running a marathon in flip-flops.
That is the perfect analogy, yes.
You're using a tool meant for standing still to absorb the shock of dynamic movement, and your body ends up paying the price.
And beyond the permanent tissue damage, there is this whole secondary cascade of physical problems.
Like what?
Well, when you don't have the proper equipment arresting that movement, your brain subconsciously tries to fix the problem for you. You will instinctively alter your biomechanics.
Oh, I see. Like you change how you move to compensate.
Exactly. You will hunch your shoulders forward to brace against the bounce. You'll shorten your stride. You'll tense your upper back.
So you are basically fighting your own center of gravity the entire time.
Which leads directly to chronic neck pain, upper back strain, and a likely breakdown of your athletic form. But by utilizing the correct load-bearing equipment, you eliminate that figure-8 movement.
You protect the ligaments.
Right. And you instantly correct your posture. You can actually breathe properly because your shoulders are naturally pulled back into their proper alignment.
See, this sets up a massive challenge for the engineers designing this equipment. Because if the goal is to lock down this kinetic energy, my immediate instinct is just to build something that straps everything to the chest wall as tightly as humanly possible.
Just strap it down.
Yeah, just heavy, unforgiving compression.
Well, that instinct makes sense on a surface level. And in fact, it is exactly how you engineer a solution for a smaller bust.
Okay, so it does work for some.
Yeah, for a petite frame with less mass, the kinetic force is relatively low. So the design focuses on compression. Use soft elastic bands and, say, a racer-back design to pull the tissue securely against the body wall.
So it acts as a single, unified mass.
Precisely. Yeah. Which minimizes the bounce without restricting the shoulder's range of motion.
Okay, here's where it gets really interesting. Because I understand how compression works for a smaller load. It's like strapping a suitcase tightly to the roof of a car, right?
Good comparison. Yeah.
But what happens when you have significantly more mass? If you take a large bust and just try to compress it against the chest wall, you aren't actually solving the physics problem. You are just crushing the wearer's ribcage.
Yes, and this is the critical pivot in activewear engineering. You have to completely abandon compression and move to a structural mechanism called encapsulation.
Encapsulation.
Right. With a larger bust, you are dealing with a heavy dynamic load. You cannot just strap it to the roof of the car. You have to build individual shock absorbers for each breast.
Okay, wait. How does encapsulation actually work mechanically?
So instead of one flat panel of fabric pushing inward, encapsulation uses individual reinforced cups to separate and surround each breast.
Got it.
This does two major things. First, it isolates that figure-8 movement we talked about, preventing the kinetic energy of one side from transferring to the other.
Oh, that makes sense.
And second, it allows the garment to actively distribute the weight. Through rigid underwires or really heavily reinforced fabric underbands, the downward force of gravity is captured and channeled away from the front of the chest.
And where does it go?
It moves up through wide shoulder straps and gets dispersed across the latissimus dorsi, which are the largest muscles in your back.
Wow. So you are physically transferring the burden of the weight from those fragile Cooper's ligaments and the neck straight into the strongest load-bearing muscles the body has. That requires some heavy-duty architecture. The source mentions, adjustable closures to lock in the tension, incredibly strong underbands, wide straps to prevent the concentrated weight from just digging a trench into your shoulder skin.
Which actually brings up a huge historical failing in the apparel industry.
Really? Like what?
Well, for decades, the standard manufacturing practice for plus-size activewear was to take a compression design meant for a small bust and just simply scale it up mathematically.
Oh, no.
Yeah, they just used more fabric and made the band wider.
I mean, I have to call out how incredibly lazy that is. If you take a wooden footbridge and simply build it 3 times wider, it is still going to instantly collapse the moment a freight truck drives over it.
Exactly.
The structural integrity doesn't scale just because the dimensions do.
Right, it fails completely because the physics of weight distribution fundamentally change as mass increases. Plus-size athletes require an entirely different architectural blueprint.
So what does that blueprint look like?
As our source material outlines, you need wider back panels to actually handle that dispersed load across the lats. You need full coverage to prevent the tissue from escaping the shock absorbers during extreme movement.
Right, you need things locked in.
And the elastic support must carry a vastly higher tension rating. But, and here's the paradox, it cannot cut off circulation.
And that paradox introduces the next major variable. We've talked a lot about static body mass, right? But that mass is moving.
Always moving.
Yeah, the kinetic energy changes entirely depending on what the body is actually doing. Like a yoga class and a CrossFit session produce 2 entirely different shear forces on the garment.
Which is why we categorize these kinetic variables into impact levels.
Okay, walk us through those.
Sure. Low impact activities, so your yoga, walking, Pilates, they generate minimal deceleration forces.
Because you aren't really jumping around.
Right, the body isn't leaving the ground, so gravity isn't multiplying. Here, the engineering really prioritizes flexibility. You need to be able to twist the spine and expand the rib cage deeply without the bra fighting your movements.
It's like choosing your vehicle's suspension system. A low-impact yoga session is like a smooth highway drive.
Exactly.
But the moment you move to high impact, like running, basketball, tennis, you are repeatedly launching your body into the air and slamming it back into the ground. It's off-roading. You are constantly fighting rapid deceleration.
And if we connect this to the bigger picture, deceleration is where the maximum kinetic damage occurs. Every single time your foot strikes the pavement, gravity multiplies the downward force on those Cooper's ligaments.
So you need that heavy-duty shock absorption to protect the chassis?
Right. High-impact bras have to act as a heavy-duty suspension system, utilizing maximum encapsulation, rigid fabrics that resist stretching, and a really locked-down fit to absorb that violent shockwave.
Okay, but this brings up a huge question for me. If I am wearing a heavy-duty maximum encapsulation suspension system designed to lock down heavy mass against violent deceleration, how am I not overheating in like 5 minutes?
That is the big question.
Right, because if you build a bra out of canvas or Kevlar, nothing is going to bounce, sure, but the wear air is going to suffocate.
Well, the solution to that exact problem lies in molecular chemistry.
Chemistry, okay.
Yeah, fabric technology is really the unsung hero. It's the invisible scaffolding that makes this heavy-duty engineering actually wearable.
Like what kind of fabrics?
Let's look at moisture-wicking polyester, which is specifically engineered for capillary action.
Capillary action, meaning like the way water moves through microscopic spaces.
Exactly. The polyester fibers are actually synthesized with microscopic channels right on their surface. So when you sweat, these channels pull the moisture away from your skin, pushing it to the outer surface of the garment where it can rapidly evaporate.
Wow, so it acts as an active cooling system.
Exactly. Then you blend that with nylon, which provides high tensile strength and abrasion resistance.
Meaning the garment won't just tear apart under heavy kinetic stress.
Right. And then there's spandex.
Oh, spandex. The source highlights spandex a lot. It seems to be like the holy grail of activewear.
It really is. Spandex, or elastane, is a polyurethane polyurea copolymer.
Say that 3 times fast.
Right. But on a molecular level, it is made of long, flexible polymer chains mixed with rigid segments. The flexible segments allow the fabric to stretch up to 600% of its resting length to accommodate your breathing and movement.
That's incredible. 600%.
Yeah, but the rigid segments act as anchor points. The moment the kinetic force stops, those chemical bonds immediately snap the fabric back to its precise original shape.
So it's that memory recovery that provides constant active tension without suffocating your ribcage.
You nailed it. You combine that memory recovery with strategically placed mesh panels for airflow and seamless construction to eliminate friction burns during repetitive motion, and you have a highly engineered machine.
But, and here's the reality of the consumer market, nobody wants to walk into a gym looking like they are wearing a medical-grade orthopedic brace.
No, definitely not.
People want high fashion, beautiful silhouettes, and vibrant colors. How difficult must it be for brands to successfully balance that demand for aesthetics with the rigid, unforgiving technical demands of high-impact sportswear?
Balancing the rigid physics of kinetic lockdown with modern fashion is incredibly difficult. Consumer demands are higher than ever.
I can imagine.
This is exactly where specialized apparel development companies, like Apparelizer, step in to kind of bridge that gap.
So how does a company like that actually solve the paradox? Because it sounds like you were trying to make a tank look like a sports car.
It requires an intense research and development process. Companies like Apparelizer handle the entire life cycle of the garment, starting with concept development.
So they don't just draw a pretty design.
No, they analyze the exact kinetic stress the garment will face. Then they move into technical design. This involves creating digital and physical prototypes to test shear forces on the seams, calibrating the exact tension rating of the underbands, and mapping out where the rigid encapsulation zones need to intersect with the flexible spandex zones.
Okay, so they are essentially hiding the structural architecture inside the fashion.
That's exactly it. They are seamlessly burying the function beneath the form. They source premium materials